Okay, so today, children, we are doing electrochemistry, the second half of the unit 9, and this is the last part of the unit. And you need to understand the meaning of electrochemistry. So, meaning is that how to use chemistry, how to integrate chemistry with electricity. So, here you are going to learn two types of cells. One is called as galvanic cell, galvanic. In galvanic cell, you are going to carry out a spontaneous reaction. Spontaneous. You already know the meaning of spontaneous reactions. Sudeep, do you know the meaning of spontaneous reactions? You can answer here in the chat. Spontaneous reaction. Okay. You have to answer everything in general chat, which everybody can see. So, what is a spontaneous reaction, children? What is delta G for a spontaneous reaction? We were doing it in the first half of the unit 9. Delta G is gives free energy for a spontaneous reaction is negative. What's the value of K for a spontaneous reaction? The equilibrium constant. The equilibrium constant for a spontaneous reaction is greater than 1. Means products are favored. So in galvanic cell, we will carry out a spontaneous reaction for which the delta G is negative, the equilibrium constant is greater than 1, and then we are going to calculate E naught cell or E cell. E naught cell for a spontaneous reaction in the galvanic cell, that's the cell potential. This value, you can see this value 1.10 volt. This is the potential of this battery, this one. Over here, this is the cell potential. So we'll learn how to calculate and how to understand the cell potentials. So E naught cell for a spontaneous reaction in a galvanic cell is positive. Means from a chemical reaction, you are generating electricity. Chemical reaction is giving you electricity. And a cell in which electricity is generated from a chemical reaction is called as galvanic cell. So we are going to learn about it. This is one type. Second type of cell. So these are very important. Your free response questions, not free response, sorry, multiple choice questions in the AP exam. Important multiple choice questions. Spontaneous reaction, delta G negative, K greater than 1, cell potential, or you can call it as EMF, electromotive forces, they all are, the value of this will be positive. The chemical reaction can give you electricity. You can generate electricity. Then second category is electrolytic cell. So I'll be asking plenty of questions on these two types of cells. We are going to learn about them in detail. Second is electrolytic cell. In electrolytic cell, you are going to carry out a non-spontaneous reaction. Non-spontaneous. And what is delta G for non-spontaneous reaction, Dhruv? What is delta G? Yes, please answer here. What is delta G for non-spontaneous reaction? Ashita, Iksha? Yes, delta G is positive. And for a non-spontaneous reaction, value of K is products are more or less? K is less than. Why? Less than 1. Why? Because products are less and reactants are more. So it's a non-spontaneous reaction. Delta G is positive, K is less than 1. Now we are going to learn about anode cell for a non-spontaneous reaction. So what are you expecting? Anode cell will be positive or negative? Negative. Yes, Kiki, very good. Anode cell is negative. And now can you generate electricity? No. So what are you doing? Using electricity to carrying out a chemical reaction. We are using electricity to carry out a chemical change. Here we are using electricity. I can give you these two examples from your daily life. You are using mobiles, right? We are using mobiles. You have a display screen. It's using giving you those displays with the help of electricity. So when you are using mobile, then it's working like a galvanic cell. There is a chemical reaction carried out in a spontaneous manner inside the battery of the mobile. Chemicals are there. So that chemical reaction is carried out and you are getting electricity and you are using that electricity for display of your screen and all these whatever we are doing on the mobile. But once the battery is dead, then you are recharging your mobile. That recharging of the mobile is you are using electricity to regenerate all the chemicals. Recharging is electrolytic cell. Electrolytic cell. So, what is a galvanic cell, children? In which electricity is generated. So, all the batteries which we are using, you are using your laptop battery. So, what you are doing in the battery, what is there inside the battery? Chemicals. What these chemicals are doing, they are undergoing reaction and generating electricity. And then you are using that electricity to for the display of your screen and all the functions which laptop is doing with the help of electricity. And when the battery of the laptop is dead, then you're recharging. So why are you recharging? Because you want to regenerate the chemicals. The chemicals of the battery are regenerated. Like for example, if this reaction A is B, A to B, this is the reaction. I'm giving a general reaction. We'll understand what type of reactions are needed. A to B. This is the reaction which is carried out during the generation of electricity. Delta G is negative. And your laptop is working on this chemical reaction. You're getting electricity. Once all the A is used up, is zero. Once the A is zero, and you have only B, then you cannot get electricity because A is not there. Then you want to regenerate your A. You want to do the reverse reaction. Reverse. If this reaction has delta G negative, what is the sign of delta G for the reverse reaction, children? Mhm. What is delta G for the reverse? Positive. A reaction which is spontaneous in the forward direction, this is spontaneous in this direction, is non-spontaneous in the reverse direction. So that is the reason when you want to carry out B to A, when you want to regenerate your chemicals, delta G must be positive. It's a non-spontaneous reaction. You cannot carry out without using electricity. So you are supplying electricity during recharging. You're using electricity to regenerate the chemicals. Sudeep, is it okay? You're not answering anything here. Sudeep, can you hear me? Okay, so are you clear about the meaning of electrolytic cell and galvanic cell, all of you? Because there will be plenty of multiple choice questions from this part. Can you answer some questions before we move on? We'll try to understand how we can generate electricity, what type of reactions can give you electricity. So we'll understand that. Before we go for it, if delta G naught is positive, what's the sign of E naught cell? Cell potential? If delta G naught is positive for a reaction, what's the sign of E naught cell? We are trying to memorize it. Yes, Kiki. What's the value of K? Greater than 1 or less than 1? Dhruv. Mhm. K is less than 1. E naught cell is negative. Are you going to use electricity or you are getting electricity here? Delta G naught is positive. Reaction is non-spontaneous. Are you going to use electricity? Yes, use electricity. Yes. So what type of cell is this where you're using electricity to carry out a reaction? What category? Electrolytic cell. Good. Okay. Now another type of question. If delta G naught is negative, E naught cell is? Yes, Sudeep. Try to answer this question. E naught cell is? Lasya? Yes, Sanjana. Good. Plus. And K will be? K will be greater than 1 or less than 1? K is equilibrium constant. It's a ratio, right? Ratio of the product to the K is greater than 1. If K is greater than 1, E naught cell is positive. It's a spontaneous reaction. Are you getting electricity or you are generating electricity? Chemical reaction can take place because delta G is negative. So are you getting electricity in this? Electricity is generated. Electricity generated. What type of cell is this? What's the name of these type category of cells? Galvanic cell. So today we are going to learn about, today I can cover only galvanic cell. Electrolytic cells we'll do in the Sunday morning class. Okay. So what type of cells can generate electricity? For that we need to understand the meaning of electricity. What is electricity, children? What is electricity? Electricity is the flow of charge. Flow of charge. Flow of charges is electricity, electrical current. Now, what reactions can give you electricity? Redox reactions can give us electricity. Redox, reduction, oxidation. This we have done in unit 4. So I'll give you some review about redox reactions. They can give you electricity. We cannot have electricity from other reactions, only redox reactions. That's I'm going to teach you today, Dhruv. Dhruv is saying how. So that's the title of the class. How can we generate electricity from redox reactions? Okay. Because during reduction and oxidation, electrons are transferred. reduction oxidation. One is losing electron, other one is gaining electrons. Electrons are transferred. And these electrons which are transferred, if we make up a setup like this setup you can see, the electrons are transferred from one reactant to another reactant through an external wire that we are going to learn. I'm just giving a brief introduction here. The electrons are transferred through a wire from one reactant to another reactant. So in the wire, electrons are traveling like this, like this. The black wire, electrons are coming like this, and then coming in the red wire, going into this solution, in this solution, coming out of this solution, electrons. So when they are traveling through a wire, then electricity is generated. You can see the voltmeter here. So during reduction oxidation, these are the only reactions in which electrons are involved. Electrons are given from one reactant to another. And if we force these electrons to move through a wire, then charge is flowing. Wires are made up of metals, and electrons are flowing through the wire. When electrons are flowing through the wire, that is electricity. That is electricity. Dhruv, is it okay? Some part is clear? Okay, so now we have to understand redox reactions in brief again because we have done already in unit 4. So I'll give you a brief review about the redox reaction and then we'll start working with galvanic cells. So what is a redox reaction? What is reduction? What is oxidation, children? Reduction is, yes, gain of electrons. Gain of electrons. Oxidation is, loss of electrons. Everybody is comfortable with this? And during redox reaction, there is a change in oxidation number. Change in oxidation number. Oxidation number is the charge per atom. It is the charge per atom. Yeah, per atom. Not on a group of atoms, per atom. On every atom, the way Lassia is writing. So, oxidation number, I will be writing like this. Oxidation number, ON. So, oxidation number is the important thing. Why I'm giving you a review of this redox reaction? Because I want you to be very perfect in calculating the oxidation numbers. Now, let's see oxidation numbers. Do you remember the rules of oxidation numbers we did earlier? How to calculate oxidation numbers? How to calculate oxidation numbers? Rules. I'm writing the rules again. Rules for calculating oxidation number. I've given you notes about it. You can check in the unit 4. There some notes are there. You can check in the on those notes how to calculate oxidation number. All the rules are there. Rule number 1. If it is free element, what's the oxidation number? Last year, anyone doing review of unit 4? Free element. What's the oxidation number of the element if it is in the pure elemental form? Yes, Kiki, very good. 0. Second, if it is a monoatomic ion, monoatomic means single atom with some charge on it. Monoatomic ion. What's the oxidation number? What's the oxidation number? Monoatomic ion. Oxidation number is the charge on the ion, the charge. Like for example, if I give you N2, all of you, please try to answer N2. What's the oxidation number of nitrogen here? Oxidation number of nitrogen here. Mhm. Nitrogen in N2. Yes, please. Based on these two rules, rule number 1 and 2. Kiki, isn't it free element? Free element. It's elemental form. So what's the oxidation number? 0. What's the oxidation number of oxygen in O3? O3, pure element. 0. What's the oxidation number of oxygen in oxide? Yes. You're understanding the difference in rule number 1 and 2? Okay. So most of the children, they do error in rule number 1. They are unable to work out the oxidation number of free elements. Maybe they are confused with the meaning of free elements. Free element means made up of only one type of atoms. Rule number 3 is for oxygen. For oxygen. You can see oxygen as oxide with -2 oxidation number, -2. You look at the periodic table, oxygen can gain 2 electrons to complete the octet, right? And you can see it as peroxide. When you see the word peroxide, then it is O2, 2 minus. I hope the writing is clear here because I need space here to give practice. Okay, Lassie is saying rule number 1 is applied only for diatomic. No, it is applied for metals also, Lassia. If I give you Fe metal, what's the oxidation number? What's the oxidation number? I'm answering question asked by Lassia. What's the oxidation number here? Yes, 0. And it's not a diatomic. It's a pure elemental form of the iron metal. Is it okay, Lassia? And she's also right in that way that all diatomic gases, we already know so many diatomic elements, N2, O2, F2, even halogens, all the halogens. Halogen, seventh group, I2, Br2, all these are pure elemental forms. Anything in elemental form, anything in made up of only one type of element. One type of element. Okay, I think rule number 1 is clear. Back to rule number 3. In rule number 3, what we are learning? That in different forms of oxygen. So when it is oxide, what's the oxidation number here? It is per atom. It's -2, right? That's the oxidation number. But when it is peroxide, what's the oxidation number? Mm-hmm. Dhruv, no. You have to calculate per atom. You are multiplying -2 by 2. That's wrong. It is -2 divided by 2. Per atom is -1. Yes. And there is one more superoxide which you can see in your firecrackers. You know, firecrackers, they give you beautiful colors. They are explosives. That is superoxides. They are metal superoxides. They are very unstable and they undergo explosion. And that is O2 minus. Can you work out the oxidation number here in O2 1 minus per atom? Oxidation number per atom. Yes, superoxide. Yes, Sanjana, very good. -1/2. So it means oxidation numbers can be in fractions. And yes, they can be in fractions. So can you see oxygen as rule can be in three different oxidation numbers? As oxide -2, as peroxide -1. Peroxide is always in this form O2, 2 minus. I'm writing in big handwriting here. O2, 2 minus. And superoxide is O2, 1 minus. And oxide is simply O -2. Now let's see the rule number 4. This is rule number 3. Rule number 4 I'm writing here. Rule number 4. Rule number 4 is for hydrogen. Hydrogen. It's very important rule again. So the rule says if hydrogen is bonded to metal, you have the periodic tables next to you, children. How many valence electrons hydrogen has? How many? How many electrons are there in the outermost shell? How many shells are there? How many shells are there? One shell, one electron. It's the very first element. You remember hydrogen, 1s1. This is hydrogen, right? So how many electrons it can gain or lose? It can gain one electron and it can lose one electron. So whenever it is bonded to matter, it's going to have -1 oxidation number. It's going to gain. Metals, they always lose. Metals, they lose. So hydrogen will gain. And when hydrogen is bonded to non-metal, is always going to be +1. +1. This is again a very important rule. I'm giving you one example. What's the oxidation number of hydrogen in ammonia? This is ammonia. We worked a lot on acids and bases. We remember we were working and taking it as a weak base. We were making buffers of it. This is ammonia. So what's the oxidation number of hydrogen here? Sanjana is saying +1. Lasya is saying +1. What about rest of you? You know nitrogen is non-metal. So like ammonia, water, Hi, H2S. In all these cases, hydrogen is +1. Agreed? And if I give you NaH, NaH, Na is metal. So what's the oxidation number of hydrogen here? What's hydrogen? +1, -1. Yes, please. NaH, -1. Because Na is +1. Metals are always positively charged. Keep saying these words in your mind because then it will help you in the exam. You can recall things. Metals, they lose electrons. They are on the extreme left side of the periodic table. They have less number of valence electrons, either 1, 2, 3. That's it. So they can lose. They don't want to gain. They want to lose electrons. Okay, this is sodium hydride. When it is H is -1, then it is called as it's an anion. Anions, they end with hydride. This is hydride. Sodium hydride. AlH3. What's the oxidation number of hydrogen here? -1. This one is also -1. And this is very important compound. MgH2. In all these cases, hydrogen is -1. That's rule number 4. Now I'm going on the rule number 5. Rule number 5 is group number 1. Group number 1, in the periodic table, what can be the oxidation number of group number 1 elements? Yes, group 1. What's the oxidation number of group 1 elements? Is always +1, all of them fixed. These rules are fixed oxidation number. Group number 2 is always, okay, these are the parts of rule number 5 only. Rule number 5, group number 1 is +1. Group number 2, group 2 is +2. And third, fluorine, very special element. Fluorine is always, yes, anyone? Fluorine is the most electronegative element of the periodic table. It is the most electronegative. Sudeep, what can be the oxidation number of fluorine if it is the most electronegative? Most electronegative means it's not going to lose, it's going to gain only. So, what can be the oxidation number of fluorine? How many electrons are needed to complete the octet? Check the periodic table, check the position of fluorine. Yes, anyone? Fluorine is always, yes, Dhruv? Fluorine is always, yes, it's -1. It's always -1. There is no other oxidation number for fluorine. So rule number 1, rule number 2, rule number 3, rule number 4, rule number 5. The last rule, up to 5, these are the fixed oxidation numbers. But the one which are not the part of these rules, you see, many of them are not the part of these rules. So the one which are not part of these rules, we have to calculate for that. So last rule is calculate for others. Calculate for others. Now how to calculate for others? Sum of all oxidation numbers, sum of all oxidation number will be equal to the charge on the species, on the compound, molecule, ion, whatever. If there is no charge, if it is neutral, then 0. If it is with some negative or positive charge, put it equal to that charge. So you will understand this better with the help of examples. I'm giving you one example. CF4. Can you work out the oxidation number of carbon here? Because I didn't give you carbon in the rules. So you're going to say, let's say carbon is X. How many fluorines are there? 4. I'm using rule number 6, children. Sum of all oxidation numbers. And what's the oxidation number of fluorine? Check rule number 5, -1, -1. What is the charge on CF4? 0. So what is X, children? What's the oxidation number of carbon? Mhm. Oxidation number of carbon is +4. Very good, Sanjana. And if this CF4 is converted into CH4, can you use the rules? This rule number 4, rule number 6. Can you calculate the oxidation number of carbon? Again, you can assume it as X. And there are 4 hydrogen. Very good, through. Very fast. The charge is 0. So it is -4. Now, can you answer one question? Carbon is going from +4 to minus 4. Is it gaining electrons or losing electrons? Going from plus 4 to minus 4, gaining or losing? Is gaining because negative charge is increasing. How many electrons is gaining? This is gain of electrons. Gain of electrons means decrease in oxidation numbers. Decrease in oxidation number. Those who are not understanding, please start asking questions because you cannot breathe this particular unit without understanding this. Breathe means you will not get even a single thing clear if you struggle with oxidation numbers. That is the reason I'm spending so much time to make you understand this. Decrease in oxidation number is gain of electrons because electrons are added. So negative will increase. It will become more and more negative, less and less positive. So that is called as decrease. So how many electrons from plus 4 to minus 4? How many? Don't you think 8 electrons? 8. 8 electrons. This number is important. You're going from plus 4 to 0 by gaining 4 electrons. Then 0 to minus 4 by gaining another 4 electrons. So total 4 plus 4, 8. CF4 is gaining 8 electrons to become CH4. This is reduction. This one is reduction. Is it okay? I'm giving you one more example. Now this time, whatever example I'll give you, please all of you try to work. Kiki, you're understanding everything? Kiki, you are there? Okay, I think she's not here. Okay, work out the oxidation number of nitrogen. Ashita, what's the oxidation number of nitrogen here? Oxygen you can check from rule number 3. It is oxide. Otherwise, it will be mentioned. Sanjana is saying is plus 5. Is she right, children? Check. Is she right? Who is going to confirm it? Assume nitrogen as X. Dhruv, Sudeep, and 3 times oxygen is minus 2. Each oxygen is minus 2 is equal to minus 1. Dhruv, can you check now? Okay, so it is plus 5. What about nitrogen here? Kiki, are you back? You're not answering anything. Check here, nitrogen. Sanjana is saying minus 3, Saranya is saying minus 3, Dhruv is saying minus 3. Let's check. X plus 3 times minus 1 is 0. Is plus 1, sorry, right? Hydrogen bonded to, yes, plus 1. Yes, good. Is 0. So minus 3. What is it? Plus 5 to minus 3. Oxidation reduction. Please try to answer, all of you. Ashita, you are there? If you are leaving the class, please do let me know. Like some children, they go for taking a glass of water or washroom. Do let me know so that I should not call your name. Sarayu, you're there? You're not answering anything, dear, today? Sarayu, try to answer. How many electrons? Plus 5 to minus 3. Saranya is saying 8, and I think she is right. Plus 5 to 0, 5. And 0 to minus 3, 3 more, 5 plus 3, 8 electrons. So what is it? It is reduction, gain of electrons. Reduction. Okay. N2 to NO2. What is it? Oxidation, reduction. N2 to NO2. What's the oxidation number of nitrogen here? 0. What's the oxidation number of nitrogen here? Oxygen is minus 2. Otherwise, they will mention. So x plus 2 times minus 2 equal to 0 plus 4. So what is it? Oxidation, reduction. 0 to plus 4. Yes, Ashita. It is oxidation. How many electrons? And remember, there are 2 nitrogen here. 2. And nitrogen is undergoing a change in oxidation number. Balance it. Otherwise, you will tell me wrong number of electrons. So first you check oxidation number is per atom. So 0 to plus 4. Per atom, how many electrons? Per nitrogen atom. Nitrogen is going from 0 to plus 4. So how many electrons is losing? One atom is losing 4. 2 will lose 8. And loss of electron, I'm going to write down on the product side. So can I define oxidation as increase in oxidation number? Increase. Increase in oxidation number. So is it clear to everyone how to identify oxidation reduction? I'm going to erase the whiteboard, one last practice, and then we'll start working with galvanic cell. Okay, Cr2 chromium O7 2 minus 2 Cr3 plus. Identify. Is it oxidation reduction? So work out the oxidation number of chromium here. This is 2, right? So oxidation number, as I said, per atom. It is per atom, charge per atom. And you can assume the charge per atom as x, but there are 2 atoms. So can I say 2x? 2x plus 7 times minus 2, because there are 2 of chromium. That's why I'm taking 2x, is equal to minus 2. So what is x? What is x? Yes, plus 6. Is plus 6. Very good. And what is the oxidation number here? Rule number 2. Monoatomic ions. Oxidation number is the charge on the ion. Yes, Sarayu. Very good. Plus 3. So you're going from plus 6 to plus 3. How many electrons? Is it losing or gaining? Is it losing or gaining? Is gaining 3 electrons. But how many chromiums are there? How many chromiums? 2. Balance it. Put 2 here. And then how many electrons is gaining? 6 is gaining. So I'm going to write it on the reactant side. Is reduction. reduction. We are good? Okay, ready now for to understand how these redox reactions are going to give you electricity. So let's see how a chemical change can generate electricity. I'm taking zinc metal, zinc solid. It has very high tendency of undergoing oxidation, and it gives us zinc 2 plus aqueous in water. It comes once it is in the 2 plus oxidation number, it will come in water. Now it is no longer solid and 2 electrons. This is oxidation, oxidation. But the other element here, because it's losing electrons, somebody should be there to gain it. These electrons cannot come in air. They are not free to move around anywhere. Then otherwise you can see electricity all around you. You can feel it. We cannot survive. Life cannot be sustained on earth if these electrons are flowing in the air, in the water. No, they cannot flow. They are very reactive. If one is losing, somebody else should be there to gain it. Means that's why we call them as redox. Reduction and oxidation, they go side by side. One is undergoing reduction, then there should be somebody who is undergoing oxidation, and electrons are transferred from the one which is oxidized to the one which is reduced. This is undergoing oxidation. These electrons should be gained by somebody. And who is the somebody here? Copper 2 plus. Aqueous is going to gain 2 electrons and is going to give you copper solid. If I carry out this reaction, children, in single beaker, then here is, I'm taking copper sulfate, CuSO4, and in this I have placed a strip or a kind of solid metal, like a bar of solid metal, metal, zinc solid. Now you leave them. It's a spontaneous reaction. Immediately reaction starts and zinc starts coming out of it as zinc 2 plus. They are coming out as zinc 2 plus. So here is your zinc 2 plus coming out. And these two electrons are gained by copper 2 plus, and copper 2 plus starts getting deposit over here. Or copper 2 plus you can see settling down as copper solid. You can see it. But here what is happening? Zinc metal is directly giving electrons to copper 2 plus. You cannot generate electricity. This setup is not good. It's a redox reaction. Zinc is undergoing oxidation, copper is undergoing reduction, but I cannot trap those electrons. I cannot make those electrons uh, in the form of electricity. I cannot use. So, what they have done, now they are carrying out this reaction in this format to generate electricity. It's a galvanic cell, children. How they are doing it? They have two compartments. So, understand this now. How to generate electricity from a redox reaction. They have two compartments. In one compartment, they have placed zinc metal. These are called as solid metals. They are called as electrodes. These are metals, electricity can flow through them. Zinc metal dipped in its own ions means zinc in, let's say, zinc sulfate. and copper metal in copper sulfate. You can see these two compartments. I hope it's clear to everyone. Kiki, you are there now? Ashita, please understand this step by step because we have to do so many such pictures. Yes, yeah, good. Very good. Okay, so now what happens? You connect these two compartments with the help of wire. The wire is connecting these two electrodes. As you connect them, zinc metal will start losing electrons. This metal, giving you zinc 2 plus and 2 electrons. These 2 electrons are coming out like this and going in the wire. They will not go in the solution because in the solution there is no one to gain them. So they will be forced to move in the wire like this, like this. And then they will enter in this electrode. Electrons are now, this electrode is full of electrons. It's full. And from the solution, this solution, copper 2 plus will gain 2 electrons to give copper solid. And these two reactions, these are two half reactions. One is oxidation, other is reduction. And we are carrying out these two half reactions in two separate containers, in two different compartments. And these compartments are connected to each other through a wire and a salt bridge. I'll explain you the functioning of salt bridge. And then electrons are flowing from one to another, from one electrode to another electrode because of their different potentials to undergo oxidation reduction. Electrons are always going from oxidation compartment. This is oxidation compartment. Oxidation is happening here in zinc metal because it has more tendency to give electrons than copper. That's why this is oxidation. It's called as anode compartment. Anode. Oxidation is anode. And in this compartment, reduction is happening. And reduction is cathode compartment. And how the electrons are flowing? They are flowing from anode to cathode. These two electrons from oxidation compartment to reduction compartment, right? And when these electrons are flowing, that is electricity. Now, what's the meaning of that? What do you mean by electricity? That is electricity. You put a bulb here. You put a bulb. It will glow. In the wire between these two half reactions, I'm placing a bulb. It will start glowing. It will give you electricity. You put your mobile. It will start working. This can be a battery. This is a battery, which generally we are having in our different electrical equipments. We are using all our battery operating, right? We have different types of battery. We are not using exactly this battery. We are using different types of batteries. They are different chemicals undergoing oxidation reduction, and you are making oxidation in one compartment, reduction in another compartment, and then you're placing your equipment between these two compartments, like here. You know, every battery has two terminals. You must have seen that. If this is a battery, it has two terminals. One terminal representing anode, other representing cathode. Wire is like this. And you can put your equipment here. And electrons will flow from anode. Electrons will flow from anode to cathode. This is multiple choice question. It's a galvanic cell. And electricity is generated. And electrons are flowing from anode to cathode. Now you can understand this very well that we need a redox reaction for it. Redox. Without redox reaction, you cannot get electricity. Okay, Dhruv, earlier we used to teach the sign. Dhruv is saying plus to minus. No, Dhruv. Now we are not using any sign for galvanic cell. Galvanic cell, we are not using any sign. The sign which you are telling me is for electrolytic cell, not for galvanic. If you talk about the galvanic cell sign, then anode earlier, now we are not using. Earlier they defined anode in the galvanic cell as minus and cathode as plus. It's easy to understand. Why? Because electrons, they always flow from minus to plus. Electrons are flowing, coming out, going in this. So if somebody asks you to give charge, so you will say, oh, cathode is positive then, because electrons are going inside it. They will not go inside it if it is already negative, right? What you are saying plus minus, that is for electrolytic. But children, don't get confused. For the galvanic cell, we are not using any charges. We are not defining any charges in the galvanic cell. If your teacher is teaching, don't worry. AP is not asking. AP has completely removed the sign convention in the galvanic cell. Is the galvanic cell clear? This one? Now, what is cell potential? Cell potential is the potential difference. You see, zinc has more potential to undergo reduction. It's a chemical nature. Zinc metal is more reactive than copper metal. It's more reactive. It has more tendency to undergo oxidation. So, the potential of zinc to undergo oxidation and the potential of copper 2 plus to undergo reduction, the difference between these two will give you cell potential. Like I can give you the magnitude of the cell potential. Like for example, zinc metal solid is undergoing oxidation and the potential is plus 0. I think 64 6 6 0.66 volts. This one. You need not to memorize anything. I can just recall it because I'm teaching, but there is no need of memorizing. Values will be given to you. And copper 2 plus has a reduction potential of 0.34 volt. Can you see this? This is oxidation potential, this one. Oxidation. This is reduction. So E naught cell is the sum of these, sum of oxidation potential. I'll give you another equation also, but right now I'm just making you understand the word E naught cell. I'm just making you understand this word. That's it. Otherwise, I'll give you another equation to calculate it. Means 0.66 plus 0.34. How much is this? 1.10 volt. You remember this value was reflected on that picture. So if you put a voltmeter here, in this wire, place a voltmeter. You're aware of the voltage of the batteries. I think boys are very much aware of that. If you put a voltmeter here, then you will see the reading as 1.10 volt. Sudeep, you are understanding this? Okay. Are we clear about it? Can you see this cell potential? Is it positive or negative? It is positive. E node cell is positive. Delta G naught is negative. K is greater than 1. It is a spontaneous reaction. Spontaneous. It means, what does it mean? It means that electricity is generated. You're getting electricity. What kind of cell is this? Galvanic cell. It is a galvanic cell or voltaic cell. And if you use a group of cells like this, in some cases we need more cells. We call it as a battery when we are using multiple cells. A group of such cells, galvanic cell means spontaneous, is called as battery. Okay, now we have more questions. Now we are going to go more in detail in the galvanic cell. Ready? This is your galvanic cell. Now we have plenty of questions. So please start answering here. What happens at the anode? What is anode in the galvanic cell? You remember I defined anode word. Anode. What is anode in the galvanic cell? Anode compartment. Memorize it. Oxidation. Oxidation compartment is anode. Then what is cathode compartment? Cathode compartment is reduction. You have to memorize it. The same words are used in electrolytic cell also. In electrolytic cell, anode is oxidation, cathode is reduction. In galvanic cell, anode is oxidation, cathode is reduction. Is it okay? Please, this is very important. You have to practice it. You have to memorize it. Okay, here signs are given, but it's an old presentation. Now AP is not asking. Okay, plus minus, don't worry about it. Okay, now this is your zinc metal. This is zinc anode. Can you see anode? Dipped in zinc sulfate solution. This is copper cathode dipped in copper sulfate solution. They are dipped into their own ions in the galvanic cell. Two compartments, anode, cathode, voltmeter. Here, this is the galvanic cell of zinc and copper. You remember we calculated the value. What was the value? I'm writing here the one which we calculated. 1.10 volt. It will give you electricity of this much voltage, right? Okay, so here what happens in the anode compartment? This reaction, where these electrons are going, where the electrons are going. Check the microscopic picture. These pictures are very important nowadays. This is your zinc solid. The zinc metal is coming into the solution as zinc 2 plus ions. Where the electrons going? Zinc is coming as zinc 2 plus. Where these electrons are going? They are going in the, anyone? In the wire. See, they are not coming into the solution. So solution is getting plenty of zinc 2 plus ions. So what is happening to the solution? Solution is becoming electrically charged. It's getting positive charge, right? And electrons are flowing out. Now let's see this picture, this one. This is your copper solid. Electrons are entering in this copper solid. Can you see electrons have entered? But immediately they are gained by copper 2 plus ions. Copper 2 plus ions, after gaining these two electrons, is becoming copper solid, right? So what is happening here? Reduction. And what are you doing? You are removing copper 2 plus. So this solution is getting excess of sulfate ions. This is becoming excess because copper 2 plus are removed. This solution is becoming excess in zinc 2 plus. Excess of this. So this is getting positive charge, this is getting negative charge. Solutions cannot be charged. Solutions cannot get charges. I think I was telling you earlier also. So in AP exam, you'll be very strongly tested for this concept. They will show you different types of solutions and they will make in some solution where some charges are there, extra negative or extra positive. Then you have to say that this solution is not feasible. Solutions cannot be charged. Solutions have to be neutral. Please write down this again and again. Solutions are always neutral. But here we are getting charges. So what does it mean? Reaction will stop. The flow of electricity will stop immediately. You'll get a flash of electricity and no more electricity. But that is not good. I want electricity. So what we have to do? We have to ensure that these positive and negative charges should not get accumulated. That's the only thing we have to take care. Take care that extra positive, extra negative are not getting accumulated. For that, we are using a salt bridge. Salt bridge is made up of ions, cations, and anions. This has a moist salt. Moist means the ions can move. It's not a perfect solid. It is moist. It's not solid here, right? So due to this moist salt, ions can move. What is getting here in excess? Zinc 2 plus. So who will move? Cl minus will come and neutralize it. It will enter here. It will neutralize this excess of zinc 2 plus. What are these? These are anions. They are called as anions. So in which direction the anions will go? Anions will go in the direction of anode. Correct? That's how they named it. Anions are moving in anode. Why anions are moving in anode? Because anode is getting excess of positive ions after oxidation. And who will move in the cathode compartment? Cations. These are cations. These are multiple choice question, children, and they will go in the cathode. So they will ask these type of questions. What charge is getting accumulated in your anode compartment? So remember, anode, oxidation. Oxidation means electrons, negative charge is going out. So what charge in anode compartment getting accumulated? The positive charge. To neutralize this positive charge, what is needed? Anions. Anions are coming from salt bridge, right? And cathode are getting electrons, negative charges entering in it. So cathode reduction, cathode is getting accumulated by negative charge. So who will come and neutralize this negative charge? You know sulfates, plenty of sulfates. Who will come and neutralize this negative charge? Cations from salt bridge. So these can be questions. Children, you are understanding this? Are you ready to answer my questions now? Dhruv, can I ask questions? Ashita, Kiki, hello, Kiki, Kiki, where were you earlier? I was calling your name. Kiki, if you have to leave your chair due to any reason, you please give me a message, right? Sir, are you ready? I'll ask plenty of questions on this galvanic cell. Okay? Remember, salt bridge is very important. If you remove the salt bridge, your solutions will become electrically charged. And then no more electricity, reaction will stop because solutions cannot be charged. Right? Anode, oxidation. Cathode, reduction. Anodes are getting extra positive charge. So anions will move from salt bridge. Cathode is getting extra negative charge. So cations will move from the salt bridge. Ready to answer my questions? Please answer here. Questions will be very simple. I'm just trying to make you memorize few things so that you have longer retention. So which compartment is anode? Oxidation, reduction. Anode compartment. Anode is oxidation, reduction. Yes, Kiki, very good. What about rest of you? Yes. Nasia, good. Anyone else? Ashita? Sarayu? Anode is? Yes. Oxidation. And which compartment is reduction compartment? Dhruv. Which compartment is reduction compartment? You know, this particular cell has two compartments. Okay, Lasya. This one has two compartments, anode and cathode. So, which compartment is reduction compartment? Cathode compartment. Good. Electrons are flowing from anode to cathode or cathode to anode? Sudeep, try to answer this question. This is very important question. Is always there. Electrons are flowing from anode to cathode or cathode to anode? Yes, Kiki, very good. Very good, Dhruv. Sudeep, good. Because anode is oxidation. So electrons are coming out from the oxidation compartment, loss of electron oxidation, and going in the reduction compartment. Okay. So during oxidation, what ions are going in the solution? The positive ions or the negative ions? You can see this picture. Try to focus on this picture, on this one. What ions? The positive ions. So what kind of charge is getting accumulated in this solution? What kind of charge is getting accumulated? The positive, right? So from the salt bridge, which ions will move? The anions or the cations in the anode compartment to neutralize the charges? The anions, anode, cations, cathode. So what is the function of the salt bridge? What's the function of the salt bridge? One simple line for the function of the salt bridge. You know, salt bridge is not there, your galvanic cell will not work. So what's the function of the salt bridge here? So in the AP exam, they give you so many options. They will say, okay, the salt bridge is helping us in flowing of the electrons. Electrons are flowing through salt bridge. That's totally wrong. Electrons are flowing through the wire, right? Electrons are flowing in the wire, not the salt bridge. So I've seen these as multiple choice questions. Electrons are flowing through the salt bridge. No. So what is the function of the salt bridge? Yes. Kiki? Ashita? What's the function of the salt bridge? Hmm. Come on, dear. Sudeep, it maintains the electrical neutrality of the solutions. Please write on this. It maintains salt bridge. I'm writing the function of the salt bridge. Maintains the electrical neutrality of the solutions. Of the solution, it helping in neutralizing the solutions. Otherwise, solutions will become charged. This will become positively charged. This will become negatively charged. And once they are charged, reaction will stop. I explained you in detail. Why you couldn't answer it? Kiki, is this answer clear? So take it as a multiple choice question, please. And they will give you different 100 options for that. Salt bridge is where we have electrons flowing. Salt bridge is helping in oxidation reduction. So they will give you all silly options. You have to read them very carefully. And then you have to pick up the right option. So electrons are flowing through wire, right? Okay, one last question. Please answer that question very carefully. Focus on this picture, this picture. So you can see that during oxidation, zinc 2 plus is coming out. So what will happen to the size of the anode during reaction? Size of the anode. Mhm. Anode is solid. The electrode, anode, solid. So what will happen to the size of the anode, Dhruv? Anode size is increasing or decreasing? Ashita? Nasya, you're back? Sanjana? So what will happen to the size of the anode? Dhruv is saying decreasing. Confirm it. Yes. Yes. Dhruv and Sudeep and Kiki are right. It's decreasing because zinc 2 plus solid is coming out. Solid is coming out. And what will happen to the size of the cathode? See this picture now. What will happen to the size of the cathode? Mhm. Is increasing. Size of the cathode is increasing. Why? Because copper 2 plus is settling down. So slowly the size of this will increase and the size of this will decrease. So that's also a question. It's multiple choice. There is a cell, anode is decreasing or increasing. Galvanic cell. The size of the anode will decrease or increase. The size of cathode, they will give you a reaction. It depends on the type of reaction. Sometimes these anode and cathode are not participating in the reaction. I'll show you some cells where anode and cathodes are not participating. But here they are participating. They are the part of oxidation reduction. So that's the story about the galvanic cell. These are important points. This is a galvanic cell. And the difference in electrical potential between the anode and cathode, the potential difference is called as cell voltage, E cell. You remember I was using E cell from the starting only. I said I'll explain you later on. It's called as cell voltage. More difference in potential, more amount of electricity generated, right? Or EMF. These are different names. Cell voltage, cell potential, E cell, like this. And here is the list of reduction potentials. Reduction potential means tendency to undergo reduction. You can see that the title of the table is Standard reduction potential. Standard. Standard means E naught, cell potential, reduction potential. These are half reactions. Oh, it's written here, half reactions. Why these are half reactions? Because they are just representing reductions. All reactions are reductions, all of them. You can see gaining electrons, gaining electrons, gaining electrons. These are gaining electrons. Electrons are written on the reactant side. So remember, this is your reduction potential table. These are half reactions, right? Reduction potential means gain of electrons. Yeah, I was telling you the meaning of standard conditions. Standard. E naught, standard. You have already heard about standard conditions when we were talking about delta G naught, delta H naught, delta S naught. All these are defined at standard condition. There's a difference. There's a difference in STP, standard temperature pressure condition of gases. STP is entirely different thing. Okay, and standard conditions are different. Standard condition means temperature 25 degrees Celsius, pressure 1 atm. If you are dealing with the solutions, then 1 molar is the concentration. If you are not dealing with the solutions, then 1 mole is the amount. These conditions are defined as standard conditions for carrying out any experiment. So these are under standard conditions. Means you can see all these are solutions. They are solutions. Aqueous. Aqueous means in water. They are solutions. So we are going to take all of them as 1 molar. It's important, children. Right now we are working with standard conditions. And very soon I will be teaching you non-standard conditions, cell potential. We'll be working on that also. Nernst equation. We'll learn about Nernst equation. That is for non-standard condition. So that will come later on. So understand the word standard condition. This table is given under standard conditions, right? Okay, now let's work with this table. Is there anyone with zero potential here? Any substance with zero potential? Any half reaction? You can see this. It's zero. This is your reference. This is the standard hydrogen. This is hydrogen. You can see H plus and H2. Electrode, SHE. This is our reference electrode. Reference. You know, when we are measuring something, we have some standard reference. You decided this length is 1 meter. So how come you decided this is 1 meter? Why not other length or some other length? Then you say, oh, it is it with respect to some reference. All the measurements are with respect to some reference. Measurements we decide based on some reference. Same here. This table is made on this reference. This is our reference value. This is assumed. We have assumed this value that, okay, let's take hydrogen as 0. Okay, reduction of hydrogen potential 0. That we have assumed. Now rest all are measured experimentally using this. What about this? If I compare this reaction and this reaction, can you tell me who has more higher reduction potential? Who has more high tendency to undergo reduction? You can see these two values, children. Please answer it because this I cannot teach you. This you have to practice. Who has higher reduction potential? Hmm. Waiting for the answer. Dhruv, are you checking the sign? One is plus, other one is minus. Plus is high or minus is high? Kiki. So who has higher reduction potential? Don't write the complete equation, just write the name of the material. This one or this one? F2. F2 has higher reduction potential, the top one. And which one has the lowest reduction potential? Lowest? Okay, now understand how to make a galvanic cell from these reduction potentials. Ready? The one which has more positive value will have higher reduction potential, will have more tendency to undergo reduction. The one which has less reduction potential or the negative value, more negative means more less, they have more tendency to undergo oxidation and less tendency to undergo reduction. When the teacher will give you two equations, like for example, this one and this one, which one has higher reduction potential will undergo reduction. The one with higher reduction potential will undergo reduction. If it is undergoing reduction, then Dhruv is right, then it is cathode. So in the galvanic cell, it will work like cathode. And the one with less reduction potential, see the second equation which I gave you here, this one. Second, I'm going to write it in the reverse manner, children. 2Cl minus giving you Cl2. Now I'm writing it in reverse manner because if this is cathode, then other one has to behave like an anode, isn't it? Both of them cannot be cathode. Both of them cannot be reductions. If one is undergoing reduction, it will force the other one with low reduction potential to undergo oxidation. That will become anode. Can you combine these two reactions? F2, electrons cancelled. They must get cancelled out. We have done the balancing of redox reaction in unit 4, and there also we were following the same rule. The electrons must cancelled out. Electrons cannot come into the solution. Electrons cannot go in the air. They are gained and lost by one species. They are locked. They go from one material to another material or they flow through the wires. They cannot jump out of the wire into the environment. Okay, so this is the redox reaction. Is it spontaneous? Let's check. Now I'm going to give you the equation. I'll calculate the E node cell to know whether this reaction can take place or will not take place. E node cell, so AP is giving you this equation. E node, sorry, E node cathode, the reduction potential, and then you are using the reduction potential as anode, so put minus. That's the equation they are using. But remember, this equation I'm using when I'm using reduction potential values. I'm using reduction potential for both of them. But of course, you know that one of them is undergoing oxidation. That's why we place minus to reverse the sign. So in front of anode, a minus so that we can get the oxidation potential. So what's the E naught cathode value, children? 2.87 here. What's the E naught anode value? I'm taking reduction potential, that's why I'm placing a minus here. 1.36. Is this answer positive or negative? What is the answer? Waiting for the answer. Please pick up your calculators. Bring your calculator during the class. We are practicing our calculators also. What's the answer? Give the answer with units. Potential has units. Everything is written here. What is the answer, Ashita? Yes, units, Sudeep. It's a measurement, it has a unit. Check the unit. Volts. Yes. So we are going to measure cell potentials in volts. Volts, I think those who are doing physics, they know this unit very well. Okay. Is this value positive or negative? Sarayu? The value is positive. It's a very simple question. Sarayu, is it positive? Yeah. So if it is positive, the reaction is spontaneous, non-spontaneous. Reaction is spontaneous, positive cell, right? It's going to generate electricity. You will get electricity. It's a galvanic cell. Galvanic or voltaic. Galvanic or voltaic. Delta G is negative. K is greater than 1. Equilibrium is going to be more in this direction. Generally, all the reactions are in the form of equilibrium, but K will be greater than 1. Means fluorine can oxidize chloride. These are very popular reactions. It's a redox reaction. And who is undergoing oxidation? Cl minus. Oh, did I write 2Cl here? Sorry. Can you do the correction, children? I think by mistake I've written 2Cl minus here. It should be Cl2. Cl2. 2Cl minus 2Cl2. It's oxidation. This is Cl. Oxidation. And F2 is undergoing reduction. Reduction. Right? If you see some error in writing, sometimes I'm so much into teaching that I have this tendency of doing minor errors. So just point out if I've done some error. So that's how you can calculate the cell potential by using the reduction potential values. If you are using reduction potential values, then you have to use this equation. This will ensure that the reduction potential value of the anode, which is actually oxidation. I put a negative here, so the sign will get reversed. Plus 1.36 will become minus 1.36. So that will give you the cell potential, the difference in the potentials of anode and cathode. Ready for another question? This time I'm not going to help you much. So keep answering my questions. I'm taking this. Please, all of you, try to answer. More you answer, more you learn. Now tell me, who will behave like an anode here and who will behave like a cathode? Which substance is going to behave like anode and which one is going to behave like cathode? Yes. Okay, again Dhruv is answering. What about rest of you? Which one has higher reduction potential? In the galvanic cell, that's going to behave like a cathode. So Dhruv is right. Cadmium 2 plus, cadmium solid. This is one reaction. And then it means if this is cathode, then anode is this one. Anode means oxidation. Oxidation means reverse reaction. Reverse means strontium solid is giving you strontium 2 plus. What's the redox reaction? Add these two half reactions. Oxidation half reaction combined with cadmium ions are in the solution. Ions are in the solution. Plus strontium solid giving you strontium 2 plus and cadmium solid. Right? Now what is E node cell? What is E node cell? E node cathode minus E node anode. And pick up these reduction potentials only. E node cathode minus E node anode. Plug in the values. Cathode is minus 0.40. Anode is minus 2.89. What is the answer? Are you getting a plus answer, minus answer? Is it spontaneous? Is it a galvanic cell? Are you getting electricity? So all these questions can be answered. 2.49. It's a plus answer. It's a spontaneous reaction. Spontaneous is galvanic cell. Galvanic. Delta G negative. K greater than 1. Electricity generated. Generated. So these are the questions. They will give you the cell potentials and they will ask you to write the redox reaction, to find out who is anode and cathode, what's the cell potential, final anode cell of the redox reaction, and what type of reaction, spontaneous, non-spontaneous. It's a very, very popular question. Very popular. It's always there in free response. They are in love with this. And it's so easy. Okay. We have understood this. One last question based on the same thing. This time I'm going to combine. I just want to teach you one more concept. So that's why I'm taking slightly different things. I'm taking this chromium and this silver. Identify who is the anode and who is the cathode. Which one is anode? This is negative. This is positive. So which one is anode? Again only through. What about rest of you? Are you finding it difficult to identify? Yes, chromium is the anode and this is cathode. So I'm going to write down cathode as such. Cathode reaction means reduction. I'm writing it as such. This is cathode. So I'm marking it here, cathode. My cathode in this cell is this, and this is anode. This I'm deciding from the reduction potentials. So Ag plus 1 electron giving you Ag solid, right? And for the anode, I will reverse the equation because anode means oxidation. Can you give me the final equation? These are in the solution. Can you give me the final equation, children? Can I add these equations as such? No. This is 3 electrons. This is 1 electron. So what should I do, Sudeep? I think Sudeep knows it. What should I do? Multiply the above equation by 3. Can you see 3 electrons? 3 electrons now cancelled? Yes, very good, Sudeep. Children, you're understanding? But when I multiply with 3, when I multiply this equation by 3, should I multiply this potential also by 3? Answer is no. Please do not multiply your potential values by the coefficients when you are balancing the equation. We were doing so with delta G, delta H, delta S. We were multiplying the whole equation by 2, delta H gets multiplied. Remember Hess's law? But here, no. E node cell, E node cell is an intensive quantity. Intensive quantity. Intensive means it does not depend on amount. Does not. So please write on this. Does not depend on amount. Whatever is the amount, you take 10 moles, 20 moles, 30 moles, cell potential will be the same. At it for per second, you'll get the same amount of voltage. Does not depend on amount, right? We are clear about it. So when you multiply the whole equation by 3 to balance the number of electrons lost and gained, do not touch E node cell. Do not do this error. I have seen some teachers, they also do error. The one who are not very experienced. Sometimes they do it. They have in their mind delta H, delta S. So they keep multiplying E node cell also. No, don't touch them. They are intensive quantities. Okay, now what is the final equation? 3Ag plus chromium solid. This is aqueous. Ions are in the solution, giving you 3Ag solid plus chromium 3 plus aqueous. And what is E node cell? You already know your cathode and anode here. You are not going to multiply them by any factor. Just pick up the values as such from the reduction potential table. This equation is valid for reduction potentials. So what is E node cathode? 0.80 minus 0.74. What's the answer? It's a plus answer. And it is 1.54 units. Units are volts. V volts, right? Is it spontaneous? Yes, spontaneous. Why? If somebody says why, because E node cell is positive. Positive. That's why it's spontaneous. Delta G will be negative. K will be greater than 1. Electricity is generated. You're getting electricity formed over there. You can use it as a battery. And what kind of battery? Galvanic cell. Combination of galvanic cells. It's a galvanic cell. Or what's the other name of the galvanic cell? Voltaic cell. I think I'm not using this word, but yes, you can call it as voltaic cell also. Okay, now here, this is galvanic cell. Every time you're getting your E node cell positive. Why every time I'm getting my E node cell positive? Because I'm selecting it. I'm selecting who is going to be cathode and who is going to be anode. So I'm doing selection according to the one which has more reduction potential as cathode and less reduction potential as anode. That's why every time I'm getting E node cell positive. I'm making a galvanic cell every time. Now I'm giving you one reaction and you're going to calculate E node cell. The reaction goes like this: nickel 2 plus plus 2Br minus, giving you nickel solid. You can see the reaction Br2 liquid. Calculate E node cell for this reaction. So nickel 2 plus to nickel solid. Is it oxidation reduction? This one. Nickel 2 plus to nickel. Check the oxidation numbers. This is 2 plus. What's the oxidation number of nickel here, children? Rule number 1. Nickel, pure elemental form, 0. 2 plus to 0. Oxidation reduction. 2 plus to 0 is gaining electrons, losing electrons, Sanjana? Kiki, what is it? Yes, it's gaining. What about rest of you? It's gain of 2 electrons. Why others are not answering? Kiki, are you there? Sarayu, Sanjana is answering. Only Sanjana is answering. You know, when I'm teaching, my eyes are on the chat. And children, I'm planning to share these chat messages in the on the WhatsApp so that parents can also see your participation in the class. It's important. You must participate. You must try to answer here. Lasya, gain of 2 electrons. Is it okay? Lasya. Okay. Now check this. What's the oxidation number of Br2 here? Very good. 0. And what is here? -1. But there are 2 Brs, right? So going from -1 to 0 is oxidation, decrease in oxidation number. It's losing. How many? -1 to 0? 1. But there are 2 Brs. So equation is balanced. Now identify who is anode and who is cathode. Yes, please identify anode half reaction and cathode half reaction. And then we are going to calculate E node cell. E node cell is E node cathode minus anode. Okay. Dhruv is saying nickel is cathode and bromine is bromide. This bromide is anode. Is he right, children? Because gain of electron is reduction and reduction means cathode. Loss of electron is oxidation and oxidation means anode. Can you plug in the values here? Anode, cathode. One reaction I have taken this. These values will be given to you. Other I have taken this. In my reaction, This is cathode in this reaction. And this is anode. Pick up the values. Minus 0.25 minus 1.07. Add them. So minus 1.32 volts. Kiki, this is minus, right? So is this spontaneous or non-spontaneous? So can you generate electricity here? It is non-spontaneous. You are going to use electricity to carry out this reaction. You need this much electricity. You have to supply electricity of this much voltage or more than that. Either this or more, not less than this. So it's a non-spontaneous reaction which needs electricity, right? Needs electricity. These are questions. It's a electrolytic cell. Electrolytic. It's not a galvanic cell. You are not getting electricity. Delta G. Delta G is non-spontaneous. Delta G is positive. K is less than 1, right? And electricity is used. These are multiple choice questions. So this reaction is not taking place on its own. You cannot get electricity. You are supplying electricity and forcing this reaction to take place. So that can be done with the help of electrolytic cells. There we are going to use a battery or electricity to carry out these type of non-spontaneous reactions. Is it okay? Okay, children. I was telling you about something about this electrode, right? This is the reference electrode. This one. The one with the zero value. This one. Now let's see the setup of this reference electrode, which is called as SHE. This is the setup. It's standard hydrogen electrode. It's a well-defined setup, very well-defined. You know, when we take a reference, we have a standard definition for it. Everything is with some parameters. So they define everything and then they say, okay, this one is our reference, and we have taken E naught for this particular half reaction as 0.00 volt for this. What is the setup? Setup is like this. Check here. There is hydrogen gas which is bubbled in a solution of 1 molar hydrochloric acid. This is the definition of the SHE. The electrode which we are using is platinum. Even this plate of the platinum, you can see the plate of the platinum. Platinum is very expensive metal. You know, children, you heard about white gold. You check with your mother, she must be aware of it. Nowadays, you see in the gold, some white lines are there. So that's white gold. In the yellow gold, the gold is yellow in color. So there you can see white lines. Many people are wearing it. It's very expensive also, more expensive than gold. So here it is platinum. This surface area, the length, width, everything is well defined. We are not going in more in detail. We have to see that there is a hydrogen gas which is bubbled at 1 atm standard condition in a solution of 1 molar hydrochloric acid. And the cell potential for this half reaction, E naught cell, for this one, reduction potential. So generally they write it like this. Reduction potential means H plus to H2, like this. is 0.00 volt. What does it mean? That 2H plus undergoing reduction after gaining 2 electrons to give you H2 gas. And the cell potential is 0.00 volt. That's the reaction which is taking place. Can you see the bubbles of H2 coming out? If the reaction is taking place in this manner, then it means it's working like a cathode. I have seen this question also. How will I come to know that this is working like a cathode here? You can see bubbles. See these bubbles? So it means reduction is taking place. But if the reaction is taking place in this manner, in this manner, how will you come to know that reaction is taking place in this manner? Means it's working like a anode. How will you come to know? You are getting more H plus. If you are getting more H plus in the same solution, then it means pH will go down. You know, pH is negative log of concentration of H plus. So concentration of H plus will increase if reaction is going in this direction. So these can be the question, this can be. But what I'm talking about, anode, cathode, I'm talking about with reference to other half reaction. Here is another compartment. And let's say in this compartment, I have some copper metal, something with E note half reaction value as plus 0.76 volt. Let's see, right? This is the value. So if this is this, then and this one has a value of 0.00, this one has 0.76 volt, then definitely this will work like cathode. Cathode means reduction here. Then this will work like anode. Anode means oxidation here. Then if oxidation, then reaction will take place like this. And if you measure the pH of this solution, pH will go down. That indicates it's working like anode. Electrons will travel like this. These electrons. You can place your voltmeter here. What will be the reading in voltmeter, children? What is the reading in voltmeter? Yes. Anode cell is anode cathode minus anode anode. So what reading will come here? 0.76 minus 0.00. What reading? 0.76 volt. Let's go back to the table. Let's see. Because here you see that the contribution by the SHE is 0. This is 0. So whatever reading is reflected here is actually the potential of the your other material, reduction potential. So that's how they have measured the reduction potentials of all the materials here. They have combined all these half reactions, this half reaction with hydrogen. The deflection in the voltmeter will be this. You combine this half reaction with this, the deflection will be this. But if you combine this half reaction with this, then it will work like cathode and this will work like anode. Correct? You know, this is more negative. Then E node cell will be, the deflection in the voltmeter will be E node cathode, which is 0.00 minus 0.76. Cell potential will be still 0.76 volt. Still the same. So are you understanding how this SHE, standard hydrogen electrode, is used to calculate all these potentials? So you're combining your SHE with different half reactions. I'm going to show you one picture here. See here. The reading here deflected is 0.76 volts. Can you see the flow of the electrons? Who is anode here? Which compartment is anode? Which compartment is cathode? Yeah, this is anode. And this is cathode. The reduction potential for this one is 0.00 volt. What's the reduction potential of this? Let's say X. Then E node cell is 0.76. That's the value which is deflected here. Is 0.76 equals to cathode, which is 0.00, this one, volts minus X volts. Get the value of X. What is X? Isn't it minus 0.76 volts? That's the reduction potential of zinc. Let's go to the table. We are going to the table to see whether we are right or wrong. The reference elect table. Here. Can you see where is zinc, children? Is the value right or wrong? Where is zinc? It's here. You can see it. It's here. Isn't it the same value mentioned here? The same. The one I was writing. We calculated. That's what I was trying to tell you. That all these half reaction potentials are measured with respect to hydrogen. The one which has more potential for reduction, they are above it. The one which has less reduction potential, they are below it. Right? Check here. Who is anode here and who is cathode? See the flow of the electrons. From there you can decide. So which one is anode and which, oh, okay, time is also up, children. So let's do this as last part. So which one is anode? This. Electrons are flowing like this, like this. This is anode. And this is cathode. If the reading deflected here is 0.34 volts, then what is the reduction potential of copper 2 plus, which is the cathode? You know that E node cell is cathode minus anode. So I can assume this as X. So X minus this value is 0, 0.00. So what is E node cell? 0.34. So X, what is X? E node cell is this. What is X? X will be plus 0.34 volts. That is X. So I'm ending the class. Sorry for holding you for extra minutes. I didn't realize that time was up. So see you tomorrow morning and in the evening, tonight and tomorrow. See you then. Bye.